Today we're going to begin talking about radical functions. The square root function is the inverse of the quadratic function. The quadratic function, if you remember, is a parabola. In the graph below, you can see the quadratic function, shown in blue, and the square root function, which is shown in red. Notice that you've taken the blue function and turned it sideways, and that's our square root function. From the graph on the previous page, we can see that the square root is not a function because it fails the vertical line test. This is because we have y equal to positive or negative the square root of x, where the positive square root of x is the part of the graph above the x-axis, and the negative square root of x is the part of the graph below the x-axis. If we only include the positive square root, then we do have a function. So in all of the examples that we look at, we're going to be looking at the square root of a function, but only the positive square root. We're going to ignore the negative part of the square root because if we use the negative part, then it's not a function. In order to graph square root functions, first you want to make a table with two columns, one for x and one for f of x. Second, we have to pick 5 x values to plug into the equation. You don't always have to choose 5 x values, that's just a good number to use to graph. Next, we plug these 5 values into the equation to get f of x. Next, we graph the point x, f of x, or fxy on the graph. Last, we connect the dots. This should give us a good representation of the square root function.
For this function, we're going to be graphing f of x equal to x minus 3. Our first step is to make a table with x in the first column and f of x in the second column. So we draw our table, putting x here and f of x here. Now we need to choose some x values to plug into the equation. So let's choose some easy ones. We'll start with 0, 1, 2, 3, and 4. So if I plug 0 into the equation, I get the square root of 0 minus 3, which is the square root of negative 3. Since we have the square root of a negative, that one's not going to work. So we can try 1, the square root of 0, or of 1 minus 3, is the square root of negative 2. This is also the square root of a negative, so we need to cross it out. We try square root of x2 minus 3 is square root of negative 1, still negative. Square root of 3 minus 3 is the same as the square root of 0. This one's okay, so the square root of 0 is 0. So that means our first point is going to be 3, 0. Our second one, we get the square root of 4 minus 3, which is the square root of 1, which is 1. And we can add a couple more points since we had to cross out a few. So let's try 5, 6, and 7. Just continuing down the list. 5 minus 3 is the square root of 2. And if we put a calculator to approximate that, we get 1.4. 6, we get 6 minus 3, which is the square root of 3, which is about 1.7. And for 7, we get 7 minus 3, which is 4, which is the same as 2. Now we can go over to our graph and graph this. So we have to mark our graph with 1, 2, 3, 4, all the way up to 7 because those are the numbers we used. And then we're going to graph the y-axis as well. 1, 2, 3, 4. Okay, so now we can graph our points. The first one is 3, 0. So we go over 3 and up 0 and put a point. Next we have 4, 1, over 4, up 1. And I'm not going to graph the fractions yet. I'm going to skip down to number 7 where we have 2. And we're going to go ahead and connect those dots. And that is the graph of f of x equals the square root of x minus 3. For this example, we're going to be graphing f of x equals x plus 1. So now we have the square root of x plus 1. We need to make our table again. So we make two columns, First column is x, second column is f of x, and we pick some numbers. So let's go with 0, 1, 2, 3, and 4. Now we need to plug those into the equation. The square root of 0 plus 1 is the square root of 1, which is 1. The next one, square root of 1 plus 1, is the square root of 2, which is 1.4. Square root of 1 plus 2 is the square root of 3, which is 1.7. Square root of 1 plus 3 is square root of 4, which is 2. And the square root of 1 plus 4 is square root of 5, which is 2.2. Okay, so we can take those and graph them on our graph over here. The first one is 0, 1, so we go over 0, up 1. The second one is at 1, 1.4, so that's going to be 1 and a little bit less than half. 3, 1.7, or 2, 1.7, I'm sorry. So we go over 2 and up a little bit more than half. Next one is 3, 2. And the last one is 4, 2.2. So 4 and then just a little bit above 2. So we can go ahead and connect the dots here. And we'll have a nice graph of the equation. F of x is equal to the square root of x plus 1.
Square root functions can be transformed using the information in the table below. A vertical translation is done by adding k to the function. The k is outside of the radical sign. So if you look at the examples, if you add 3 to the end of the radical, then it moves 3 units up. If you subtract something from the end of the radical, it moves down. For horizontal translation, you subtract inside the radical. So if you subtract 2, you move 2 units to the right, and if you add 1 inside the radical, you move 1 unit to the left. Notice that for the vertical translation, you leave it the same, and for the horizontal translation, you have to make it the opposite. This is the same as it was for quadratic functions when we use vertex form. For a vertical stretch or compression, you have a number in front of the radical. The coefficient, if it's larger than 1, it's going to stretch it. If it's less than 1, it's going to compress it. The horizontal stretch or compression is inside the radical. If it's inside, you have a horizontal stretch of 5 for 1/5. If you have a horizontal compression of 3, you get a compression of 1/3. Notice that for the vertical stretch, you use the number that's in the equation. For the horizontal stretch, you use the reciprocal of the number inside the expression. Remember, the reciprocal is turning the fraction upside down, replacing the numerator and denominator. A reflection is done by making A or B negative. If A is negative, then it's reflected across the x-axis, which means it's turned upside down. And if it's reflected across the y-axis, the negative is inside the radical. This means it's flipped across the y-axis.
Now we're going to try graphing by translation. Here I have the parent function f of x is equal to x squared already graphed here in blue. We're going to be trying to graph g of x equal to the square root of x plus 5. Since we're adding 5 onto the end, our k is 5. If k is 5, that means we want to move the graph up 5 spaces. So we go up 1, 2, 3, 4, 5 spaces and put our first point. We move the next point up 5 spaces, 1, 2, 3, 4, 5, and the point after that. We move this one up 5 as well. So now we can redraw our line, translate it up 5 spaces, and this is the graph of g of x equal to x plus 5. For this one, we're going to be graphing g of x equal to the square root of x minus 1. Now we have the 1 inside the square root, which means that that's going to be our h, not our k. So this is going to be h equal to 1. If h is 1, we want to move to the right one space. So we take our first point and move it over one space. We take our second point and move it over one space to the right. And our third point and move it over one space to the right. So we go ahead and connect these, and we'll get the graph of g of x equal to x minus 1. So everything is moved to the right one space. For this translation, we have a factor in front of the square root of x. So we have to divide all of the points by 1/2. So what we're going to do is make a table of all the points that we've plotted here. So the original one, f of x, has the points 0, 0, 1, 1, and 4, 2. If I cut all of those in half, I get 0, 1/2, and 1. I get these by cutting f of x in half. Half of 0 is 0, half of 1 is 1/2, and half of 2 is 1. So now I have all of my new points. The first one is still 0, 0. The second one is 1, 1/2. And the third one will be 4, 1. So now I have a very similar graph, but it's going to be a little bit shallower than the original. And that's my graph of g of x equal to 1/2 the square root of x.
Here we have a very succinct summary of the table that we had earlier. We have f of x is equal to a times the square root of 1 over b times the quantity x minus h plus k. Remember, a is the vertical stretch or compression factor. If a is less than 0, it's a reflection across the x-axis. If b is the horizontal stretch or compression factor. If b is less than 0, you're reflecting across the y-axis. H is your horizontal translation, and k is your vertical translation.
For this example, we're going to be transforming the graph f of x equal to the square root of x to get g of x equal to minus the square root of x minus 4. Using the equation that we were given, we can see that a is equal to -1. A is what's in front of the radical sign. And h is equal to +4. We don't have a b or a k because there's no coefficient in front of the x and there's nothing added outside of the radical. Now we need to figure out what it means to have a negative a. Well, negative a means we reflect across the x-axis. And then if h is +4, that means we translate 4 units to the right. So when we graph this, we're going to want to reflect across the x-axis and translate it 4 units to the right. Go ahead and try to graph that and then check your answers using the next slide.
This is the graph that you should have gotten from the previous example. Notice that it's been translated 4 units to the right and flipped over the x-axis.
Okay, for our last example, we're going to transform g of x equal to -3 times the square root of x minus 1. And here's our formula that we're going to go ahead and use. So a, in this case, is -3. That's the number in front of the radical. There is no h, or h is 0. And our k is -1. This means that we're going to, first of all, be rotating around the x-axis. We're going to be flipped over. So we're going to be reflected And remember, that means it's flipped upside down. We're also multiplying by a scale factor of 3. So we have a scale factor because remember in the previous two examples, our negative was a negative 1. Now we have a negative 3, which means we have to multiply all of our points by 3. And k is negative 1. Since k is negative, we're going to be moving down 1 unit. So go ahead and try your graph for this one and check your answer with the next slide.
This is the graph you should have gotten for example 3. Notice that it's been translated down 1 unit, reflected around the x-axis or flipped upside down, and stretched by a factor of 3. So instead of the point 1, 1, we're going from the first point over 1 and down 3, and that's how we stretch it by a factor of 3.
Now we're going to be working backwards. We're going to write the equation for a function that transforms f of x equal to the square root of x, so the parent function, by reflecting it around the x-axis, compressing it by 5, or 1/5, and translating it down 3 units. So instead of taking the equation and graphing it, we're going to be describing the graph and writing the equation. So if we're reflecting around the x-axis, that means that we need to have a negative a. We don't know what a is yet, but we know that it needs to be negative. Now compressing it by 1/5 gives us a as 1/5, so we make a negative 1/5 because a is our compression factor. Now if we're translating it down 3 units, we're going to be telling what k is, and k is going to be negative 3 because negative means we're moving down. So if we want to write out our whole equation now, we plug in a and k. So we get g of x equal to negative 1/5 times the square root of x minus 3. And that's our final answer. G of x equal to negative 1/5 times the square root of x minus 3. That'll compress by 1/5, translate around the x-axis, and then translate it down 3 units. For this last example, we're going to write the equation for a function that transforms f of x equal to the square root of x by reflecting it around the y-axis. We also want to vertically stretch it by 2 and translate it 1 unit to the right. So we have our function written down here. G of x is equal to a times 1 over b times x minus h plus k. So g of x is equal to, and we have to find out what different numbers we're plugging in. So first, we know that we are reflecting it around the y-axis. Since we're reflecting it around the y-axis, we know that b is going to be negative 1. Because there's no horizontal stretch, it's just going to be negative 1. Since there is a vertical stretch, we make a 2, because that's the vertical stretch. And we're translating 1 unit to the right. The right-left translation comes from the letter h, so we make h 1, because we're moving 1 to the right. Now we plug these into the original function. A is 2, minus 1 times x minus h plus k, which we can simplify to 2 times the square root of negative x minus 1. And that's our final answer. We have g of x is equal to 2 times the square root of negative quantity x minus 1.
This is the graph you should have gotten for example 2. Notice that the graph has been translated up 3 units and has been reflected across the y-axis.